So the second video today is reviewing a bunch of the old stuff. Thursday of this week, you're going to be taking the practice STAR algebra test. So we just want to kind of throw a few things up. It's not a formal review, but it's just, let's go work a few problems that we worked earlier this year and see what we remember, just to kind of put some things back in our heads. It's not an official review. We just want to see on Thursday what you know, but we may as well review a few things while we're doing it. Now, we didn't do factoring very long ago. So if you remember, if they give you both factors, you could put them in the calculator and just multiply them together and see which one will equal that. So that is perfectly a good way to do it, is to put it in the calculator and do that. You could also factor this by hand if you wanted to. You could set up your two parentheses. All right. Oops, my pen's not working right there. I mean, right over here, maybe. There we go. Okay, so you could set up your two parentheses and say what times what will equal a W, and of course it's W squared, and that's a W and a W. And then you say what two numbers multiplied together equal the N number. And you make a list, 1 times 4, 2 times 2, you make a list of all the factors. To know which pair of factors, you add them or subtract them. If I add them, I get 5. I subtract, I get a 3. Ooh, that works. If I add them, I get a 4. If I subtract them, I get 0. Neither 4 nor 0 were my numbers, so I'm going to use the 1 and the 4. And you can see down here that they used all 1s and 4s. Then you had to come up with the signs. And of course, it needed to be, let's see, a positive 3 is an answer when I add them. So I'm thinking make the 4 positive, and then make the 1 negative, and I try adding them in the calculator, making sure I get a positive 3. And then I need to multiply them together, and they need to equal a negative 4. So both things have to happen. You could also do it down here by multiplying the answers together with the double distribution, or just check that the first two give you W squared, and when you multiply the last two, they should equal a negative 4. Well, negative times negative gives you positive 4, so hopefully you cross that one off if you did this checking the answers. Positive times positive gave you a positive 4, so not that answer. Positive 4 times negative 1 is negative 4, and negative 4 times positive 1 is also negative 4, so both of these are in the hunt. Now, remember I told you guys, so if you had you done it this way, then you could come back and check the math for the addition problem. So now we've multiplied to get the negative number. We know it's one of these two. If you add them together, they should equal 3. Positive 4 and negative 1, if you add them together, will give you a positive 3. Negative 4 plus 1 will give you a negative 3, so which one works? It's C. Now, if you did it by hand, or whether you did some other version, or whether you multiplied the answers or you factored by hand, you got the same answer. It was W minus 1 and a W plus 4. It doesn't matter what order they are because they're being multiplied together. So they put the W plus 4 and the W minus 1 together. But I want to remind you there's a way to check this in the calculator. Normally we didn't do this before, but since we're getting ready for the STAR test and we have a graphing calculator, you can check your answer in the calculator, and I highly encourage you to do that. Now, before the real STAR test, we'll have this down really good. This is an expression. I can't put that in the calculator. I need an equation. If I want to graph this in the graphing icon, I've got to go and look at the picture. I need to be able to have a y equals. So all I got to do is just take that piece and make a y equals in front of it. If one of these is equal to it, and I put y equals in front of it, so y equals parentheses x plus, or w plus 4, close parentheses, w minus 1, close it. Now, when you put these in the calculator, can you put w's? No, you're going to put x's where the w's are. But if you put this one in, graph it, then hit the tab key, and then type this one in and hit enter, because that makes the graph. Both these graphs should be right on top of each other if they are equivalent. Okay, so that way you know. Now, what if you didn't want to do any of this by hand or multiply any answers? Could you just put this one in, and then one at a time put each answer in and see which one went right on top of that? Yes, that's another way to do this. Okay, factor. These, they gave you both answers. In a minute, I'm going to show you, wait, what if they didn't give you the second answer? You can't put that in the calculator, but it won't make the exact same graph. This one's going to make a lovely parabola, but if you don't have the second one, you can still put in y equals w plus 4. But when you put it in the calculator, what it's going to do is your original one did this, and you got your two x-intercepts. If you put in all these answers, y equals w minus 4, y equals w plus 4, y equals w plus 4, y equals y minus 4. Two of these are going to go through each other. Yeah, when they give you a single answer, you're not going to have two answers that are the same. But let's say they gave you just a set of 4 different answers over here. 3 of them are going to do something weird, and 1 will go right through the x-intercept. You're wanting the one that goes right through the x-intercept. And of course, C would have gone right through the x-intercept. So that's how you can do them, even though they don't make the exact same parabola. If you have the whole thing, it'll make the whole parabola, and they'll just match up right on top of each other. But if they were to give you answers that just had a single factor, then when you put each of those answers in with y equals in front of them, they're going to make straight lines, and you're looking for the straight line that goes through the x-intercept of your parabola. And again, we'll practice all this before the STAR test. Don't worry about it if you don't get it right now. Again, we're factoring. So again, we could go double multiply all these at double distribution, see which one works. The first two multiplied together should equal the first one, and the last two multiplied together should equal the positive 3. Well, positive times negative is a negative 3, so we're crossing it off. Negative times positive is negative 3, so I'm crossing it off. Positive times positive is positive 3, keep it. Negative times negative 3 is positive 3, so we're keeping it. Now, because this one has this number in front, you just can't add them together to get that middle number, because obviously none of these, if you add them, give you that. You're really going to have to go to the double distribution to figure out which answer works. Or you could put them in the calculator and do y equals, and then put each of these two answers in with y equals, and see which one goes right on top of the original parabola. So that's one way to do it. And let's see, hopefully if you've done that, I'll give you pause the video and go do that, see what you come up with. And the one that worked was D. D was the right answer on that one when you do it. Okay, so anyway, if you did that one, that's a good way to do it. Is just put that in the calculator, put both of these in the calculator, see which one goes right on top of the original one. Or just go do the double distribution and then combine your like terms. Again, factoring. When they just give you two pieces, because normally when you factor, it is a trinomial that we're trying to factor into a binomial times a binomial. Now notice they gave you two binomials multiplied together except for number one. It says x plus 4 squared. Rewrite this x plus 4 is being squared, so rewrite it as x plus 4 times x plus 4. So now you can literally just go multiply all the double distribution and see which one matches that. Remember, the middle term is there, it's just you don't see it because there's a 0x in front of that. So that helps you remember that when you add them together, it should equal 0. If you add 4 and 4 together, do you get a 0? No, not when you add them. And a positive 4 and a positive 4 gives you a positive 8, so it is not A. A negative 4 plus a negative 4 is a negative 8, again, not the 0. A negative 4, ooh, this one doesn't make sense at all because this is 3x squared times x, which gives me 3x to the third power, which doesn't match my first piece even. So I got rid of that one. And of course, x times x is your x squared, and positive 4 times negative 4, let me add them. Positive 4 plus negative 4 does give me my 0, and when I multiply positive 4 times negative 4, I get the end piece. So D does work. Now, on star test day, I would check your answer. Put in the original one with y equals in front of it. Put in your answer that you think it is. If they are identical, then they will make the exact same parabola. So you can always check your answer. Now, it's been a long time since we've done sequences. So I want to remind you, we had two different versions. We had ones that we added or subtracted to get the next one. Those were our arithmetic sequences. And we had sequences where you multiplied to get to the next one, and those were called geometric. So those were in the second unit. Now, we could, if you remember that you always see the first term in the nth formula, and then you can also see the math that's being done. So if you happen to remember that, you might be able to figure this out if you can look to see what the pattern is. And if you look at the numbers, you might see, oh, we're adding 2 each time. And you can see over here that you're adding 2 in this one right here, so I'm pretty sure it's this one. And what was the first term? Negative 4, and you can see the negative 4 right there. You'll always see the first term in it, and you'll see the math right after that. Same thing over here. The first term is a 5, so you're looking for an answer that has a 5 at the very beginning. It's not those two. So there's my first term, and then what we're multiplying by. So it's either 5 times negative 4 equals the next one, or 5 times negative 2 equals the next one. So that's one way to do that. An easier way to do these, purely calculator. Make a little table out of this. This is your first term, second term, third term, fourth term, fifth term, sixth term. So your x numbers are first, second, third, fourth, fifth. First term, second term, third term, fourth term, fifth term. The sequence is your y numbers. So just put them in the exact same order that you see here. There's your first term, negative 2 is the second term, 0 is the third term. Then you can just put each of these equations in the calculator one at a time and just match the table. Control T gives you the table, right? A sub n is your y. And then over here where the n is, that's your x. So you just type in each of these equations very carefully and just go check the table and see which one matches that table. Same thing here. Here's this lovely sequence. You could, if you remember the formulas, but they're not going to give those to you on the STAR test. You have to memorize that. So rather than memorizing a bunch of formulas, what you might want to do is just make a table out of the sequence. 5 is the first term, so 1 is 5. 2 is the second term is negative 20, so 2 is negative 20. So just write the x's 1, 2, 3, 4, 5 in order. That's all it is. First term, second term, third term, fourth term, fifth term. And then write the y numbers right next to them in this order. 5, negative 20, 80, negative 320. Or just write them in order. And then just put each one of these equations in the calculator and see which one matches this table. Control T. A sub n is your y. And then over here, this n, now on these, this parentheses n minus 1 is the whole exponent raised up high. So after you do this negative 4, you have to do the rooftop key, and then parentheses n minus 1, close parentheses, all as the exponent up there. So just to be aware that those are small exponents. This n minus 1 is an exponent. And then just find the table that matches, or find the equation that matches the table. So you're just going to do those one at a time, putting them in. Which one matches, by the way? Let me remember to see which one worked here. Did I figure it out already? I can't remember if I did or not. Oh, I think, it was B, A. There we go. I forgot what I was doing because it was multiplying times -4. Okay, so just matching tables. So always look for the easy way to do these. Find the equation of a line parallel to this line. Now remember, parallel lines are like railroad tracks. If this one has a slope of 4, this one has a slope of 4. They have the same slopes. So this is a tricky way for them to give us the slope in kind of a backhanded way. I want the equation down here that is a line that's parallel to this line. So I just need to know the slope of this one so I can see the slope down here. They're in y equals format, so the number in front of your x is your slope. But is this equation in y equals? No, it's not. So what do we have to do? These are the ones we have to solve by hand because there's a y and an x in there. You cannot put these in the calculator. So that's why we practiced a lot the first semester getting y by itself. So get rid of the x term first. This is a positive 2x. We're going to subtract 2x on both sides. The x's are gone. Negative y comes down. Rewrite this side because x is in 2. That negative 2 can't go together. Now, this is a negative 1 sitting here. We don't want a negative 1y. We want positive y. So how do you undo multiplying by negative 1? You divide by negative 1. If you do it to one side, you do it to both sides over here. Now, it is in y equals. The only thing I want to know is this number in front of the x because that's my slope. So if you put negative 2 over negative 1 in the calculator, it tells you it's a positive 2. So the slope of this line is 2. My line is parallel to it, so it also has a slope of 2. So that means it's either A, but it's not B. It's not C. It's either A or D. Now, how do we know which one between these two? Because not only does it have to have this slope, it has to go through this point. Can I put each of these equations in the calculator and check the table? In the table, right, Control T. If x is 3, the y should be a 1. That point will be in my table. So just go check the table for both those points and see which one it is. I know y'all remember doing these. Find the equation of a line, and here's the equations that's perpendicular to this line. Now, remember perpendicular. They intersect at 90 degrees, which means if one is positive, the other one's negative. So they're going to have opposite signs. Not only that, but you have to flip or inverse the actual slope of one. So if you know the slope of one, you know the slope of the other one because you're going to take the opposite sign and you're going to flip it upside down. If this one has a slope of positive 2/3, this line will have a slope of negative 3/2. I flip it upside down, 3 over 2, and take the opposite sign. One is positive, one's negative. Okay? So, good news is I just need to know the slope of this line. This one happens to be in that y minus y1 equals m parentheses x minus x1 format. So the slope in this one, the m, is right here in front of this. If you forget that, you can still solve for y. But the easy version is to remember that this number right here is your slope. So my slope is negative 2. But that's not my perpendicular slope. The perpendicular slope would be positive, and instead of 2 over 1, I'm going to flip it and it becomes 1/2. So the slope of my perpendicular line is 1/2. So if you come over here and look, it's not A, and it's not C, and it's a positive 1/2, so that means it's not B either. What's the only one that has a positive 1/2? D. And then it also needs to go through this point, so I would just double check by putting it in the calculator, check the table, make sure that 10, -3 is a point on my table. Domain, these are looking for the x numbers, and here's the lovely graph. Remember closed circles, that point will have a line underneath it, and this one's going to be an open circle, it will not have a line under it. All the x's, these are my x numbers that I'm looking for. The graph started at -3, and the graph ends at 4. It never goes to the left over here, it never goes to the right. They want to know in this picture what x numbers are being used. And we're literally using all the x's between -3 and 4. So let's go find something with a -3 and a 4. Those don't have the right numbers. Yes, no, yes. Now, the -3 should have a solid line underneath it. -3 solid line, yep. -3 open line, nope. So it should be B. And then the 4 should have no line under it. And sure enough, the 4 does not have a line under it. So remember your open circle and closed circles, whether they have lines or not. 16, same thing, except this time range. And range are the y numbers. So now it's these numbers. Okay. How high did it go? It went all the way up to, I'm going to count the lines, 1, 2, 3. It went up to 3. Did it ever go above 3? No, because this thing ends here. But down here, is this a dot? No, it's got an arrow. It's going to keep going down forever. So it's going to go down. I'm going to use all the y's less than +3. So if my y's are below, that means they're smaller. If they're smaller, I'm not going to eat the y's. I eat the bigger ones. So we have a 3 and a y. 3 and a y, 3 and a y. It's not this one. So it's one of these three. This one says x's. Am I looking for x's? No, get rid of that answer. So this one is eating the y's. That means the y's are bigger. Are my y's bigger than 3? No, my y's are below 3, so I want smaller. Does this one say the y's are smaller when the pointed in is to the y's? Yes. The 3 is being eaten because it's the bigger one, and 3 is bigger, so yes, C. Domain, again, x numbers. So we want the numbers from here to here on the x-axis. This picture never goes to the left of this number right here. But on the right-hand side, does it stop here? No, it's got an arrow. It's going to go right. So I want all the x's to the right of -4. On the x-axis, if you're going right, these numbers get bigger. So my x's are bigger than -4. So I need an x and a -4. Yep. Long number, y, long letter, x. +4, it's not that one. And this says the x's are bigger, which means I should be eating the x's, and that matches that. There we go. Again, looking for the x numbers, the domain. So these numbers here along the x-axis, I'm starting here at -2, and I'm going to 3. So all my x's are between -2 and 3. So let's see if we have the right numbers. -2 and 3, nope. -1 and 4, nope. -2 and 3, yes. -2 and 3, yes. Now let's go check the lines and no lines. The -2 as an open circle should not have a line. There's the -2. Which one do I want? Yep, that one. And this one should have the solid line with the line underneath it. So that one's right. Okay, so just a little review on that stuff. The last page is, again, more review stuff. If I can turn the page. There we go. Solving. So for solving an equation, if it's an equation, we can put it in nsolve. If it's two linear equations, I can put them in linsolve. But this is not an equation. It has an inequality symbol. So when you're getting ready to solve, inequalities typically have to be solved by hand because these are some that you can't do in the calculator. However, before you get going, get rid of any answer that does not have a line underneath it. Okay? Now, we don't know which way the inequality is going to be turned because when we're solving, sometimes we have to flip the inequality symbol. If you multiply or divide by a negative number in the process of solving, you flip the inequality symbol. But since this one has a line under it, my answer should have a line under it. So that means B is out of the question because there's no line in that one, and D is out because there's no line under it. So get rid of these before you even start solving. Now, we can solve this one by hand, but I happen to notice that this number and this number are two different numbers. So one way that you could do it is pretend that this is an equal sign and go put it in the calculator under nsolve and just see what the number is. Is it a -2 or +2? So that's one way to do this one without having to do any math involved. Had these numbers both been -2 or both been +2, then nsolve is out and I have to go solve by hand. So let's remember how to solve by hand real quick. You simplify. Nothing to simplify on the right. Before you get started solving, you're going to simplify. But I want to distribute that, right? So I still have x minus 1, and 3 times -4 is -12x, and 3 times -3 is -9. And that is still less than or equal to x minus 34. Continue to simplify. Nothing still to simplify on the right, but over here I've got x's that can go together. -12 and +1 is a -11x. It's going to get really scrunchy here. And -1 and -9 is -10, and that's still less than or equal to x minus 34. Nothing left to simplify, nothing left to simplify. They are not like terms on either side. So now I need to get x's on one side. Are x's already on one side? No. I'm going to take the smaller number over to the big number, so I'm going to add 11x. That's just it. You can go either way you want to, but I like to go from the small to the big. So now I have -10. And I can add and subtract all day and not flip my inequality symbol. +1 and +11 is 12x minus 34. The x's are now on the right. I need to get rid of the 12 and the 34. We always undo add subtract first. So add 34 to both sides. Rewrite it again. And adding, subtracting, I don't have to flip my symbols. Now this is a +24. Yeah, 24. Is less than or equal to, where did my x's go? There they are, 12x. Now I'm going to come back and divide both sides by a +12. Dividing by a +12 means I do not flip my symbol. So x's are left on this side, and it still stays this way. And 24 divided by 12 is 2. So x's are bigger than the 2. So let's go find the one that says x's are bigger than or equal to. Oh, where did my equal to go? Yeah, x's are greater than or equal to the 2. See how the x's are being eaten on this side? See how the x's are being eaten on this side? So, and it's +2. Yep, double check my sign. There we go, +2. So C is the right answer on those. Solve for x. Now, this is an equal sign, so I can put this in the calculator under nsolve. I don't have to rearrange it. I'm not graphing it. I'm just going to go to the add subtract screen, menu 3-1, go find my nsolve, menu, look for the word algebra because that's what class we're in, and then we have numerical solve or solving a system. This is not a system because it's not two equations, so we're picking the first option, menu 3-1. Type it in, at the end put a comma x, close your parentheses, hit enter, and it will tell you what x is equal to. And x was equal to a positive 1. No solving by hand needed for these on the STAR test. If you did solve by hand, take your answer and go, well, actually, you don't take your answer, but just take the problem and go put it in nsolve and double check that your answer is right. There's no reason to ever miss one of these on the STAR test with the graphing calculator. All right, find the slope of the line. Again, if you look at your reference sheet under linear, you see one that looks like this. Can you see the m? That is your slope. Can you see this equation? Does it look like this up here? Yes. So -3 is my slope. So I don't even have to do any math. It's just -3. So use that reference sheet and it will make life easier. Otherwise, you have to solve by y by adding 3 to both sides. And then y is by itself, but you got to simplify this right side, so then you have a -3x plus 12 plus 3. Oops, 12. There we go. And then this is your slope number right there, -3. And then these two like terms combined together is for your y-intercept. Okay, write the equation of the line going through 2 points. If they give you 4 equations, we just put them in the calculator one at a time. Check the table. 2, -1 should be a point, and 3, 4 should be a point. We did a bunch of these before. Just put them in the calculator, check the table, Control T. Hopefully you did that and you came back and said, ooh, D was the right answer. So again, pause the video, go see if you remember how to do these, and then come check with me, see how you did. Write the equation of the line describing this. Again, 4 equations in a table. Just go put each equation in the calculator, Control T, see which one of these matches this. There's your x number, there's your y number, x number, y number. It needs to match all the points, or at least 2 or 3 of the points. Don't just check one point, check at least 2 or 3 points, make sure it matches. And which one did? B matched. Okay, here, solving a systems of equations. If you got 2 equations, you go to LinSolve, and you type them in just like that. You don't have to rearrange anything. LinSolve is under the add subtract screen. Hit menu, look for the word algebra because that's the class you're in. Choose the second option, which is solving a systems of equations. Type both equations in, and then just hit enter. And it will tell you the ordered pair. That's where they intersect. This is where those 2 lines intersect. Okay. Remember, when on systems of equations, what we're doing is we're graphing the 2 lines and looking for where they intersect. That point is a solution of both lines at the same time. If the lines were parallel when you graph them, then there's no solution. And if the lines were right on top of each other, then there's infinite solutions, right? Okay, let's see what else we got here. Down here, we just want to graph. Which graph matches this lovely inequality? It is in y equals format, so the slope is the number in front of this. Is this a positive slope? It is. Are they all going up? Yeah, they are, so that didn't rule anything off. Is this inequality symbol have a line underneath it? No, so remember, if there's no line underneath it, it's a dashed line, and if there's a line, it's a solid line. Does that get rid of any? No, but usually you can get rid of a couple of answers with dashed or solid line. All right, so let's get more detailed now. The y-intercept is at 3. So come up here, is it crossing at 1, 2, 3? And these are counting by 2s. So this is 2, and 3 is right there, so yes, that works. How about this one? Is it crossing at 3? 3's up here? Nope, so let's get rid of this one. 3 is right there, so that one's still in the hunt. This one's crossing way down here at -3, so this one's not the right picture either. So we have 2 pictures that match the y equals mx plus b part. Now, shading. They either shaded this side of the line or they shaded this side of the line, and we need to know which one it is. If the y's are bigger, being eaten, then we shade above the line. If the y's are smaller, because y's get bigger going up and y's get smaller going down. So if y's are smaller, we're going to shade below the line. So since this is where the line is crossing right here on the y-axis, this is where the y's get smaller. They shaded below, right? They shaded below. It means the y's are smaller. So that means they would be this thing. Is that what I have? It is. So A would be the right answer. This one was shading above the line. See how they didn't shade below? They shaded above the line, which means the y's were bigger, which means it should look like this. But that's not what we had. All right, last one over here, find the range. That's the y numbers. All the y numbers being used in the picture. Do any of the y's this picture ever go above this? No, so if you come straight across, and then of course there's arrows on this probably going down, so that I want all the y's smaller or less than +3. It's not all real numbers. Y's are smaller, so it's going to be on the small end. It doesn't say the y's are bigger because they're not going up, so it's not that one. Are they or equal to? It's solid up here, isn't it? That's a solid line, so it's or equal to. So it's not D, it's going to be A. Remember, the vertex is the point up here, and the vertex would be the ordered pair, 4, 3 over 4 up 3. That would be the vertex. If they ask you for the max, it would be the y number in there. If they ask you for the axis of symmetry, the equation down the middle is x equals 3, the x number. So remember all those lovely little details that we had. And of course, the x-intercept zeros or solutions are where it's crossing the x-axis at positive 3 and 5. Okay, that's our review for today. We'll do another review on Wednesday.